Og værsgo.
Hello, everybody. My name is Ditte Lisgaard-Vind. I am the Chief Innovation and Science Officer here at Blockshop, and today I have the pleasure of doing the introduction to today's science talk. The science talk today, we have the privilege of having Mohammed Iman with us, all the way from Vancouver, to highlight how buildings can integrate with agriculture, and also give us a sort of a front row to some of the frontiers working with how to integrate technology into hopefully creating a better and more sustainable future within the built environment and through the built environment. But without taking too much time, because I know Mohammed has a lot to share, I will just quickly introduce him. He is a PhD senior researcher and associate at Perkins Will. So without further ado, Mohammed, the floor is yours. Thank you so much for joining us.
Thank you very much for this introduction. Just a heads up, I'm hearing, well, not anymore. I was hearing echo, but all good. This is a pretty important topic, and that's why I'm waking up at 6 a.m. here in Vancouver. It's worth it, so I'm happy to be here. So in this talk, I will be sharing building integrated agriculture and how it relates to where I live in Canada. I think it's one of the most important topics in our time. It has a direct impact in both sustainability, architecture, and food security. So I think it's very timely. In the talk, we'll have a general understanding of why this is important, and we'll get a primer on the uses of this technology, and we'll use Vancouver as the epicenter, the focus, to understand how it can be integrated and how policy can help drive this topic forward. And we'll also highlight how Perkins Will is leveraging policies locally and gaining more experience on projects in Canada, and how that is affecting our projects globally. So this was supposed to be my introduction slide, but Diti did a great job of doing so. So I'll just hint as to why this topic is important to me. I consider myself as a citizen of the world. I've lived, worked, and studied in multiple places. Whether it's the deserts from my hometown in Egypt to the farmlands in UK, or the open fields in China, or now the forests in Canada, they all show how the ecosystem can be bountiful, and how if we live with it in harmony, we can benefit from it. But also, I've seen in many countries and many cities that if left unchecked, the development and its rapid growth can impact this ecosystem. So it gives you that reminder of what we're advocating for and what we're fighting for. So that's me. Now, this is where we start jumping in right away. I want to start off by taking a look at agriculture throughout history. And historically, cities developed around where food was available, how we can grow food. And this is the Uruk city, by the way, and considered one of the oldest cities around the world historically, and it developed because it had that capacity to grow food. And throughout history, over the civilizations, whether it's ancient Egyptians, Persians, we survived and flourished because of our command of this technology, agriculture. And this also shaped how we built, how we developed our architecture. This, for example, is wind catchers in Persia, where it absorbs the cool air and manages to reduce the temperature of underground areas that are made to store perishable foods. And that is how you can live throughout the seasons with this type of architecture and this type of development. And it's only until the technology started to advance throughout the Industrial Revolution This is where we started separating agriculture from the cities. We said farming, that's not for the cities, that's more for rural areas. And we started mass producing food throughout vast areas of land. And each cycle of industrialization, each cycle of technology that came in benefited us quite a bit, of course. But with each advancement, we were not really mindful of how or what we're losing along the way. We continued to strain our farmland, and our food miles continued to grow, and the transportation of food from the areas that is being grown back into the cities kept growing to feed that growing population. And now, because we continue to strain our farmland on our cities, and with the recent shocks to our system and our global economy, we're starting to realize that we need to bring back our food culture and our growing cycles back into the city. But before we get into how we do that, I'm just going to go through why we're experiencing these shocks and how that's impacting our world today. So I'm going to start with some facts. By 2050, the climate impact on food security will be unmistakable. 68% of the expected 10 billion people will live in cities. 80% of the food consumption will occur in cities. This can be potentially an economic opportunity, but at the same time, it's also a foresight into where the stress in our ecosystem will be. We saw how blocks in our supply chain can be felt more rapidly than we realized. A simple barge in the Suez Canal caused a ripple effect on the supply chain that affected the world economy for months. We also seen how the COVID pandemic affected our food supply in supermarkets. So what will happen when there's a global large-scale weather event that affects the food supply? Particularly now that the climate events are increasing in frequency and magnitude. These shocks are already felt throughout the world, and also in areas that are dependent on the imports. We know now that the temperature rise more than 4 degrees Celsius will endanger the ability of farms and ecosystems to adapt. It's part of that research the body of research that we develop. The water cycles will be different and less predictable. We anticipate that the intensity and frequency and seasonality of precipitation is going to change, and that will also affect the groundwater and river flows. Whether it's droughts, hurricanes, fires, these are all impacts that we feel today. And being from Vancouver, we feel it quite a bit every season. And this is a recipe for disaster. This is an interesting diagram that was created by our partners in SHL. It shows how direct impact climate events can have on the world economy and the way we live. With decreased food yields and the threat of local security, biodiversity loss, decline in health, and its subsequent impact, this is what we will face if we don't act on this matter now. Right now, supermarkets and our everyday reliance on the global economy, it provides this illusion of food security. But we know now, specifically after COVID, that this is not the case. We've seen how simple disruptions in the global economy can affect for months the world. In fact, we know that in many cases, supermarkets can only have or do have supply for a few days and a few weeks to satisfy the requirements of its people. And that's, again, a recipe for disaster. And this impact is not just on the supply chain. Because of the rapid growth, because of the climatic conditions, many areas around the world that are large producers of food and producers of critical items of food are measuring a huge decline in their crop yields. And not only that, but because the development around the world is occurring more rapidly than planned in many areas. This is Cairo, by the way, this is close to my hometown. The developments of the city centers are easily overtaking the areas that are reserved for farmland. You can see that in the 1970s, we relied on these open field areas for agriculture, but in the 2000s, you can see a stark difference between how we used to live with the farmland and how now, in many cases, unplanned settlements overtake this growth. And this is a paradox, because the area that is reserved to sustain life in these areas are now declining because there's a lot of growth happening. And this is felt around the world. This is the same issue faced in many areas where farmland takes over forest, then urban developments take over farmland. It's the same issue in multiple areas, and that's a case that needs to change. From an emissions perspective, food production accounts for 26% of the global emissions. It's comparable with the energy consumption of the built environment, and that's massive. Just having this amount of energy and emissions required to sustain our food is dramatic. And out of this 26%, almost 19% is due to food miles, which is moving the food from one place where it's produced to its consumer. And that's also dramatic. That needs to change, this system. To add another level of complexity to this is food waste. A third of world's food goes to waste. Most of this occurs in cities, in the city centers, which is responsible for 8 to 10 GHG emissions. North America and Europe, in fact, have the highest food waste due to consumption, while Africa and Southeast Asia, you can see, has the highest percentage of food production waste. And these are all data and information that needs to be addressed. So with all these challenges that we face, with all these complexities, we have a pretty hard equation to solve. We need to understand how we can feed 10 billion people by 2050, and at the same time, without using more land, while lowering emissions. So this is a hard equation to balance. And I think this is where building integrated agriculture has a room to play and an impact that can it provide. So we know that we need to have some changes in our diet. We need to shift production zones into our cities. We need to have an integrated system of food, water, waste, and energy. We need to simultaneously, as we shift production zones and farmland into the city, we need to restore damaged farmlands and forests. This is the most straightforward way to solve or help solve these issues. And building integrated agriculture particularly focuses on these two middle zones. So for the sake of resource security in the face of climate change and the system shocks, I believe that the way forward is a decentralized system for resource generation. And that's to ensure that hyper-local self-sufficient supply. Building integrated agriculture can provide secure, equitable, local, healthy source of food and provide this buffer from radiation to extreme heat and cold. This can also help with the heat island effect, and we can leverage our systems within our building to manage stormwater, to manage waste, whether it's grey water or any food waste that is generated from the occupants of the building. It also helps provide sanctuary for habitat for pollination and wildlife. And this will dramatically improve health and well-being of its occupants. So there's a lot of benefits of having building integrated agriculture in our ecosystem. And for context, building integrated agriculture is one aspect of resource circularity. There is a huge aspect of integrating renewables into the system, material sourcing, focusing on adaptive reuse models at the beginning, life cycle assessments, waste, energy and recycling, and then food. It's not just one, it's just one piece of the puzzle. And this is where integrating this into our cities and decoupling the growth amount with the land available and using this height of a building and that Z direction can really benefit the food supply. This is Canada's Earth Tower. It's designed by Perkins Will in Vancouver. The client is Delta Land Development. It's a huge 33,900 square feet, and it was designed or envisioned to have zero emissions and designed to pass house standard. However, as far as I know, this project is in a holding pattern at the moment. But regardless, I still view this as a milestone project where both the architect and the developer came together with this clear focus of providing this resource circular system. So it also had an emphasis, as I mentioned, it's not just one aspect. It had emphasis on renewable energy, PVs, geothermal. It had productive rooftops. It had terraces that were productive, terraces and balconies. It had unit integrated gardens, provided mass timber for material resourcing, and it was very high in operational efficiency. So I consider this as a successful design project that leveraged resource circularity. And generally, Perkins Will, which is where I work, is already pushing the boundaries of resilience in design. We're on top of the operational energy game. We're addressing carbon impacts, embodied energy, material health, but generally, and this is not Perkins Will specific, generally the whole industry has a blind spot when it comes to food, how to integrate it into cities, the nutrient cycles. This is the missing link, and I think this is the most important. So now that we're in the topic of building integrated agriculture, let's start with some misconceptions. Urban agriculture cannot be commercial. This is a huge misconception. They cannot be profitable. Many of them, many people, when they think urban agriculture, they think community gardens, they think school gardens. They don't think of high-tech vertical farms or greenhouses or others. So I don't think that this is the accurate description of building integrated agriculture, urban agriculture in general. I think many people think that this integration cannot have a meaningful impact on the food supply, and this is also a huge misconception. I think having multiple aspects of integration and building and urban agriculture can definitely provide a significant impact into the food supply. And building integrated agriculture is one piece, obviously, of the farming approach. There's multiple areas that you can leverage into a building. You have a choice between farming methods that are less resource intensive or more resource intensive. It requires more technology or more reliant on their passive ecology. You have the systems where it can use natural soil. It can be constructed grounds. It can be indoor growing or outdoor growing or hybrid. It can leverage water cycles that are more efficient and grow different types of crops based on the choice of system that you use. There are many, and I'm not going to go into each one because for the sake of time, but I'm happy to share this information with anybody who asks for it. And also, based on the type of farming method that you use, the amount of crop yields and the requirements for their integration differs. So some types of farming are most beneficial at the ground level, and some systems that are lighter, such as generating microgreens, for example, does not require that type of weight and does not require that much of water, so it can be leveraged anywhere in the building. It also depends on what crops you're looking to grow. Are you looking to grow commercially, or are you looking to grow just for your community, just for your occupants, just as a hobby? So it really can be tailored to your needs and your requirements. And there is an obvious synergy of integrating farms into our buildings. There's the easy understanding that integrating this type of production in our buildings can directly satisfy its occupants with the food supply. You can also benefit from redirecting the food waste from the occupants, which is a lot, back into the systems through an on-site composting or an on-site anaerobic digester to provide direct fertilizer for on-site farming that is based on soil. You can also leverage the heat exchange between what a greenhouse requires and what an occupant may need in their unit. Also, the CO2 exhaust from a unit can also help the growth of a local farm. So there is obvious synergies here that we can leverage just by integrating farming into our system. So as I said, there is many types of farming that can be integrated into a building. You can have productive walls. You can also have different types of farming in there. You can have hydroponic rooftop greenhouses, productive green terraces, hydroponics, microgreens, rooftop greenhouses and terraces, aquaponics, indoor vertical farms that does not rely on outdoor daylight. And you can also have mushroom harvesting, which does not require lighting at all. And all this is going to benefit the food supply of your occupants and your building, and also can leverage the food waste from your output. And this can also be directed into an anaerobic digester for the fertilizer, as I mentioned. You can also decouple and separate the waste from liquids to solids and redirect this back into your supply. Anaerobic digester has a very good byproduct of energy and heat that can help also the same production system. And the water supply can also benefit from this integration, as I mentioned. And only after you exhaust this cycle of circularity within your ecosystem, you can then start relying on the outside grid, not before. And as we highlighted before, there's a great exchange of heat and CO2 between the residential units, or the units in general, whether it's residential or office or what have you, and the integrated farms. So there's a lot of opportunity here, but there's also a lot of challenges. And these challenges, I like to divide them into 4 areas. We have the technical boundaries, regulations, operations, and economics. This is not a new topic by any means, but we still lack the in-depth knowledge of integrating this into our buildings. We have, as we design and as we build, we have infrastructure limits, structural requirements if we're adding rooftop gardens, structural bracings for the balconies, electrical, mechanical system upgrades. There's a lot that comes with the infrastructure as you're adding farms and more weight into your building. There's urban pollution. If you're leveraging a productive wall, for example, you have to be cognizant that you're right in front of a street that has a lot of exhaust from cars. So how does that look like onto your production? There needs to be some calculations here. Water management is also something that we need to examine closely, similar to waste management. Scaling up. This is always the issue for farms that are commercial. They have a huge problem in terms of scaling up. Pollination is something that is less known as a problem, but it's one of the bigger ones as well. When you have a building integrated agriculture and you're thinking of having fruiting plants, you need pollination. And for liability reasons, that's always an issue, having bees around or having some, especially when you're scaling up, because when you're in a smaller system, you can manually do these systems, but when you start scaling up, you need to rely on something else. So there's a lot of research happening there as well. Regulation, there's always zoning constraints. How much FSR is allowed for integrating farms, building codes, city policy, and this is where Vancouver particularly excels. Operations, there's a huge issue for maintenance, because in many cases, you will find that the architect wants it, the developer wants it, the city wants it, but the occupants don't need to, or don't want, or at least fear of integrating this into their building because they're worried about the maintenance. There's also supply chain hurdles of the materials that you need, the true carbon impact as well, because when there is waste that needs to be recycled, when there is materials that need to be cleaned, there is an obvious tax to us. And in many cases, in our current calculations, we don't fully account for the full life cycle of urban farms. So this also needs some more research. And then finally, the economics. And this is where many issues arise, particularly in the field globally. We've heard a lot of urban farms that close shop because of investors pulling out. And this is still felt, but currently on the upward curve now. And generally, my personal notice from the industry is that when investors come into this field, they treat it as a tech company and not as a farm. So they're expecting returns much faster than a farm can provide. And this is where the disconnect happens. So we need to always be upfront and clear about this investment and this time horizon. Yeah, so there's a lot similar economic boundaries to this system. And now let's go into some case studies that are really leveraging this technology. So I'd like to make a plug for a publication that was developed by our partners at SHL, and I understand that Blocks also was a sponsor, the Hacktivist Guide to Food Security. It has a lot of examples and case studies for building integrated agriculture and urban agriculture in general, if you want to know more. But for this particular examples that I'm going to show, I'm just going to go very quickly in them. So this is the Persona Group project. It's I view one of the most successful integrations and most diverse integrations of building integrated agriculture. It grows up to 200 species of fruits, vegetables, and even rice. So that's quite impressive. And it's independent from the season. So it's self-reliant on its ecosystem. And what I also like about it, it's very creative palette of production zones. So you have areas such as productive facades, for example. You have herb boxes, benches that house seeds, the corridors that have a zone within them that contains growing greens. You have hydroponic chambers. In the reception, they even have this rice field that greets people, and this is very culturally appropriate for its location in Tokyo. Ceilings that grow herbs and tomatoes. Partitions that contain whether it's leafy greens or even fruiting plants. And on site, the canteen is leveraging all this growth into its daily diet and daily production. And I think this is one of the most successful and diverse integrations of farming in a building. Another example of also a successful integration, but however not as diverse, is the rooftop greenhouse of a market garden in Germany. Now, this one is a bit different because it does rely, in fact, on the seasons of its location. It only produces within a 10-month period from February to December, and it mainly produces strawberries, herbs, vegetables, leafy greens, and it's relying on drip irrigation. There's also soil deep float hydroponics as well. So it is not as diverse from the Persona project, but it's still quite rigorous. And similarly, they have quite a palette of production as well, but they mainly rely on deep flow hydroponics, which also they have a very integrated system for lighting to manage the requirements of plants, and they have an on-site research facility that can push the boundaries forward as they grow. Another example that I think is very successful and is closer to home, it's the Montreal-based Lufa Farms. And they've had quite a story. They've already had, I think, 6 or 7 so far, commercial farms. According to them, anyway, in 2011, they built the first commercial rooftop greenhouse, and it was part of an adaptive reuse project. And then they moved onto a larger site of also a green rooftop production zone that is specifically designed to support rooftop farms, and it's optimized for energy, water, and waste flows. And then they grew even more, and they started having a zone that is just dedicated for leafy greens. And their biggest farm yet was produced in 2020, and that is also in Montreal, and it's actively producing crops for its local inhabitants. And it also has an online shop that sells these products to the larger market. And I think this is one of the most successful commercial integrations. However, they do have some challenges as well. They have some challenges in terms of the availability of their customers and the retrofit integration into buildings. So it's not without its problems. I want to also give a shout to a new project that I made aware of in Dubai, which is Food Tech Valley, which I think is one of the bigger projects that we need to keep an eye out for, because Dubai, for example, has a huge food security issue and water scarcity issue. So if anywhere in the world that this integration is timely, it's in areas such as Dubai. And then I'm going to go quickly into the case study of Vancouver and why Vancouver is facing urgency in terms of food security. We face almost annually large wildfires in our farmlands. We experience huge floods almost annually, and it affects a lot of crops. This also impacts a lot of animals that are directly linked into our supply chain. And this is resulting into legislation that can support the integration of farmland in our buildings. This is an opportunity that we started to realize, where legislation such as the food systems is developed to provide clear ways forward for integration into large development sites. It has a clear way forward for production of these crops, for integration, for processing and access and waste. And we're already seeing that this legislation is changing some new topology and providing new topologies into our local building stock, whether it's urban farms or standalone farms, green rooftops, and building integrated. This legislation and this policy was introduced in 2018, so it's not necessarily new, but it's went through a series of amendments to refine it. And when we say this legislation is directed at large development sites, it's particularly focusing on a size that exceeds around 500 square foot of development. So that's either you're talking about a land parcel that is almost 8,000 square meters, or a point tower of 60 floors, or a tower and podium, which is usually one of the most common topologies in Vancouver and in Perkins Will, or a mix of topologies. And part of this legislation, it requires the integration of 3 food assets. So when they say 3 food assets, there's a variety of assets that we can choose from and integrate into our design. We're talking anything from low-tech as community gardens, edible landscape, up to high-tech intensive, such as urban farms and controlled environment agriculture and other innovative systems. However, the policy does still need work. It's more directed into urban farms in general. It does need some refinement into its zoning policy and some relaxations on the building integration in terms of electrical and mechanical and structural support, so it can help easily integrate these new policies into adaptive reuse projects and not just standalone urban farms or outdoor urban areas. And as soon as this legislation came into play in 2018, it started triggering a lot of projects that we have in Perkins Will. These are just a sample of the projects, large-scale projects that we have in Perkins Will that are currently running and currently require to include building integrated farms. And this brings me to our work right now at Perkins Will. Just to recap, this is what we were presenting to our people in Perkins Will to highlight the importance of this, relating to the GHG emissions, the food circularity concepts, and waste to resource systems. We have a huge group of partners that are working on a collaborative research. It's a multi-year project that starts with our design framework and direct policy response. We're also developing design aid tools that optimize and help designers reach their goals faster. And we're also prototyping and integrating this into our buildings directly. We have a huge partner group, as you can see, including our partners at SHL in Copenhagen, and UBC, University of Oregon, and local farmers as well. So within our research, our areas of inquiry are very clear. We're focusing on understanding the growing systems. We're connecting the water. What are the cycles of energy recovery and cogeneration, and the operational systems as well, and its business case. And throughout our exploration, we're going to be obviously focusing on the human-centric aspect of this integration. And this is directly applied to all our projects that are coming online. And our framework is being developed of how to have a direct response to this policy, because as of yet there is no clear directive from the city. It's not prescriptive policy. It's up to us to integrate it and to prove to the city that this is what satisfies their requirements. And we know from the case studies that we went through very quickly that there is a huge palette that is possible for us to use from, and that we can use easily into our design, whether it's from productive walls, facades, furniture, partitions, and so on. We also identified that there is a huge need for digital tools to optimize this process. It can get complex quite rapidly, and we need to leverage the tools available to us. This is timely as well, because the more projects that need this, the less the more ask they will be needed from the project. So this is an example of the tools that we are building on. It's a developed tool from MIT, and it's basically takes the project that you're developing from your design program and highlights the potential yields based on the crops you choose, and also highlights the water consumption potential, the energy consumption potential, and the waste cycles as well. However, I think it does need some work on terms of the waste cycles, and this is where our involvement is going to be. We're also trying to integrate this directly into our established workflows. We mainly use Revit in our work, and having this direct connection into our platforms will definitely help our designers. At Perkins Will, we have a huge history of leveraging computation in our work. So we already have these lines of established design processes that take advantage of multi-objective optimizations, whether it's to optimize unit layouts, daylighting, energy consumption, views, thermal comfort indoors. We already have these workflows established. We are now trying to leverage these established workflows and tie into them another objective, which is the optimization and the integration of urban farms. So when we start highlighting within our system, we want to optimize our rooftop for integration of certain crops. We can highlight and link the type of crop production into the open area in the rooftops to maximize their yield. That's if it's indeed reliant on the seasons and the outdoor climate. We're also starting to tie in some machine learning to shift from this sequence of simulation to predictions. We already started testing some of the machine learning algorithms out there, Daylight, Gem, but however, we are developing our own in-house machine learning system for daylighting. And I think this is also one of the opportunities that we have to link building integrated agriculture into our already established systems. One of the other machine learning aspects that we started testing, not quite as often as daylight, but still starting to experiment with this, is predictive layouts. And this can be very useful when we're starting to input the requirements for urban farms, the building integrated urban farms and controlled environments, because it has a clear requirement of what goes where and what is the optimized version of this environment. So having a predictive model can really boost this integration and its optimization. And in the end, we're trying to customize how our systems work within Vancouver. As I said, we have a catalyst here in Canada to boost our expertise into the system and leverage this example for our projects globally. So we have a clear directive of what we need to integrate into our system, and we're starting to create some prototypes for dashboarding that can be live as the project is being developed, that can show you the environmental requirements and the crop yield potential and the system types that can be beneficial to your system. This is very early in it's in its infancy at this point, but it's still very promising. And I think leveraging policy in Canada can really help Perkins Will as a company and also this industry as a whole. So with that, I'm gonna pause. I did fast forwards through a bit of the slides, so I'm happy to take questions now and also come back to a few items that anybody wants to hear more about. That's it. Thank you.
Thank you so much. It was really, really interesting to hear all of the great work and thoughts in regards to building integrated architecture and agriculture, sorry. If there are questions either online or in the room, I'll give you a second to just reflect, and then maybe I'll start with a question. When you think about the future of cities and how you would like to see building integrated agriculture, how much of our food supplies is produced within the city, taking, cost and demand for the square meters, calorie density of vertical farms, all of these things into account? How much do you see, and how do you see us moving towards that in the next decade or so?
Well, thanks for the question. And I think one of the important aspects to put into this equation is the amount of waste that will be emitted once we integrate more and more of our agriculture into our cities. As we said, we have a huge percent of waste, depending on country, let's say around 30% of waste just from the production zone to the consumption area, from farm to table. So when you think about it, just in simplistic terms, moving this from its farm, or the critical parts of it from the farm into the city, you're gaining 30% more. So production-wise, you don't have to have an equal amount of production relative to the farm. You just have to bring it closer to home. You just have to bring it closer to the people that grow it and eat it. And as we heard, that it's going to be around 80% of food consumption in the cities. So it makes sense to move that supply in there. As to the exact number, that's something that we need to research more globally, and because it differs based on the diet of the city. A North American diet is very, very different than a diet in Copenhagen, than a diet in Egypt, for example. So, and also the types of crops and food types is different. So having this hyper-local capacity of the residents to control their own food and control their own types of food that they would like to eat and that they use is also helping, or can help, into this type of production.
Thank you very much. Yeah, it did. Just one thing maybe with the calorie density and what you see growing within the cities. Will everything grow in the cities, or are there things that we will have with a more soil elsewhere? How do you see that?
We, as of yet, I think it's an economical issue. I think we are relying on the more valuable crops and the crops that can be grown easily. Right now, we're focusing on the first easy thing that happened was the microgreens. It's following with rooting plants, and now fruiting plants as well starting to come into play. Not everything will be economically viable to produce in the city from an economical standpoint, but maybe from a security standpoint, it should. I don't see that a critical crop like rice, for example. That's why I was very happy to see it in the Persona project. it was an example, but production-wise, I think still it makes sense to make it into the traditional method. But some high-value crops, whether it's microgreens or even medicinal crops that can be used in medicinal purposes, that makes sense to push it into the cities.
Thank you so much. Do we have questions and comments from the audience? Otherwise, I'll just continue, which I'm happy to do. You, of course, you gave us both on the agriculture side, but also with daylights and everything, and it's something that I think a lot of our community is super interested in. How do we go from talking about technology as part of the solution to really integrating it? And you have quite a lot of experience with that. So can you just share a bit about that journey, and maybe if there are some of the architectural studios in the Nordics that are listening in, trying to grasp how do we get started with, let's say, machine learning or something of that sort? Do you have any sort of tips on how to grasp that grand thing that we're all talking about, but might be a bit difficult to get our hands around?
Well, absolutely, and I think this is also a tool. It's similar to any tool, because many people kind of worry about training models with that type of data, but I view it as similar to computation. It's just another means to optimize our workflows and understand and almost see things that we or make connections that we couldn't make before. And in terms of computation or machine learning in general, I think in terms of performance optimization, linking machine learning to performance upgrades, whether it's from daylight optimization, thermal comfort, wind flow analysis, mechanical system sizing, even future climate predictions. These are all analysis that we're currently doing in our studios. And when I say in Perkins Will, I mean. So we're already taking this and linking it into our systems, because there is a huge opportunity from this technology to democratize this this optimization. Before we needed and when I say before, we're just talking about a couple of years ago. We needed a lot of machines and a lot of high quality machines to make a few simulations for daylight, for example, so that we can assess how does this look like into our or impacts our project. Now we can simulate thousands of examples just by well, not simulate. We can predict thousands of options based on the machine learning model that we trained in-house. So having a sample of a model, having a sample of simulation of how the building will be performing in certain scenarios, you can easily use that data and train a model so that it can understand, if you make this change mixed with that change, what will that result be? And it becomes more predicted. However, this comes with the caveat that it's not, let's say, 100% accurate. And depending on the simulation and depending on the complexity of the output, this let's say accuracy percentage can be acceptable within a range of 5 to 10% even. So 5% is easily to take it when you're measuring energy simulations. 10%, even 15% is acceptable when you're looking at daylighting. So this is something that that we're applying right now into our work, and I expect many studios are already working on this as well, in terms of in academia and also in competitors in the industry.
Thank you so much. Especially thank you for sharing so much of your knowledge so generously, and not least for getting up this early in the morning to do so. It's been a really inspiring talk, and it's been very nice to get an input on what you're doing across the world. So thank you so much.
Thank you very much.